Our next presentation is by Tata Elxsi, by Ramesh Ramanathan, will be the presenter, and they will tell us about their orchestrator, that is their distribution of orchestration that is based on OSM and the way of enabling 5G deployments. Okay, over to you, Ramesh.
Thank you, Francisco, for the introduction. So thank you all for joining us today. So today we'll be looking into sorry about that. We had technical difficulty. So today we'll be looking into first. So why we started this journey with OSM? So since we are part of the ecosystem, OSM ecosystem, we are proud to be part of it. We just want to give a small background as in what is Tata Elxsi and why we wanted to invest and take part in this open source community. And that going forward from that, so mapping that to what we want to do and where we saw OSM fit in. We look into where OSM fits in the digital transformation space, especially from the perspective of an operator. End-to-end from the national core to the edge, why open source MANO is an excellent choice to orchestrate the services, the products and the solutions across the various domains. And then post that, we'll also do a bit of a deep dive where we look at this transformation space more from an integration point of view to give the audience a view on in the bigger picture how OSM would fit into say the OSS space as well as the southbound space. And then we look into and to take a use case based on OSM, we'll take our distribution TEOSM, and then we have a few demo videos lined up which will take this concept from theory to practice. So moving forward, for a very quick introduction about Tata Elxsi, we started overall this journey around in this particular domain around 15 years back, where we had our own WiMAX stack, we had our LTE eNodeB release 8 compliance stack. So we were primarily building wireless systems. So from there, we migrated to the software centricity open source cloud native world, where we started building digital experiences across different use cases like IoT, connected cars, etc. So here in this digital journey, we saw a need for an orchestrator that can help us to do the different rollouts, build the networks, also co-play with some of our internal solutions like our IoT platform or the VOD platform. So in this regard, we were excited about what OSM MANO offers to us, and that's when we decided to become an official distributor with TEOSM. So to make this TEOSM more of an OSM ecosystem, so we have started building various partners and solutions around it, so that OSM, more than just being a service orchestrator, can be a bigger piece of the puzzle in terms of the collaborations and the pre-certified onboarding and partner ecosystem it can bring along with it that can help solve customer problems, especially focusing on the verticals where Tata Elxsi is also strong, like in automobile, telecom, broadcast, media, and healthcare. So this is the overall picture and vision we have around OSM. So with this in mind, so where we see it fit in, what started our journey is, of course, the whole digital transformation, network transformation part of it, which brings in the software centricity. So this includes, bringing in OSM to orchestrate solutions that stretches from the national DC all the way to the edge to commission the different services and products and solutions. So this in a 5G perspective, of course, is a lot exciting because this enables us to bring in use cases like ultra low latency, high broadband, and MPC communications. So network as a service, right, to put it simply. So that's where we envisioned OSM as an enabler for the end-to-end network, where through services and slices, which we see represented in the the dotted red and blue lines, a combination of VNFs, CNFs, going from greenfield or standalone 5G SA or from brownfield to greenfield migration where services can be a mix of VNF and CNFs. TEOSM is brought in as an orchestrator based on Kubernetes and Helm charts to control it. So with this being the bigger picture where the network fits in for orchestration. So like I said, we'll just do a small deep dive in terms of from the fitment perspective. So as OSM orchestrates these end-to-end services, it has to of course be integrated with the next generation OSS, which is what we try to project here. So this includes your digital experience in terms of the e-commerce portal, self-care portal, a designer studio, as well as an integration layer for your workflow automation, which we'll see later on. We have integrated workflow automation into OSM as well. And then so the power of this integration is in the fact that OSM and TEOSM offers APIs where we can mix and match the functionalities between what OSM and the OSS responsibilities are. So for example, a policy manager can be driven through that's what is represented in the light blue, can be driven through the information model as well can be triggered using the northbound APIs based on a decision that's made at the OSS layer. So this gives an integrated view in terms of how the NG-OSS and OSM can be coupled for achieving the telco goals. So this same deep down we now see differently. So with this we'll close the theory part before we go on to the demos to illustrate these concepts. So we saw the network as a service, and then how it fits in the deployment with the OSS. And then this is more on the southbound where we talk about the assurance workflow part of it. So OSS was covering more the fulfillment. So we wanted to give a quick picture on the assurance side as well. So where in a large scale deployment from your national to the HDC, TEOSM can be deployed in a distributed monitor as well, where from multi-source we can collect the data with localized monitoring, where your monitoring and your configuration can be locally installed at the DC level, for example, in the edge. So the data doesn't need to go all the way back to the central national DC. Local processing can happen, edge analytics can happen. In fact, we are tying up with our AIML Center of Excellence to bring in intelligent operations as well. So localized operation, edge analytics. So with this, we are able to process the data, configure data locally, and only send what is back necessary to the central data center. So with this distributed deployment, multi-source monitoring, we get the flexibility in the assurance workflow as well. So with this, I'll stop on the theory part, and then I will go on to some demos to illustrate these. So to cover these concepts, first we'll start with the installation of OSM to the TEOSM methodology. So this gives an idea on how we can exploit the microservices architecture, Kubernetes and Helm based. So this is powered by TE Gallop, which is our internal Puppet based framework, where it's a Puppet based system where you have a Puppet master, and then you have the worker nodes with the Puppet agents, where through the input data we can configure all the services. This can be doing the installation procedure, this can be doing the upgrade procedure, rollback, etc., where it can be either the software update or it can even be a configuration update. So through this, we configure the K8 master, we install all the worker nodes, we have separated the VCA separately, and then with this installation, we can go ahead and actually commission OSS in the network that we envision. So now moving on to the actual demo part of it, a quick walkthrough of the salient features. So Puppet we went through for the security reason. It gives you an end-to-end security since it's based on certificates. A centralized deployment mode along with the distributed commissioning of services, multi-node, multi-environment, multi-site, and then high availability and resilience, especially from an open container attached storage perspective. We'll be seeing each of these quickly in some demo shots. So first we'll start with the flow of the demo. So how it works is TEOSM starts with first, installing the Puppet master and then setting up the Kubernetes cluster, and then it actually goes ahead and installs the K8 master, the VCA, and then deploys all the stateful and stateless pods. Of course, having said this, it can also install on an existing cluster as well. It's only a configuration option. So this video is more to show it from the scratch, assuming there's no infrastructure. So first we start with the Puppet master installation. So once the Puppet master is installed, we get all the configurations files ready. So Puppet works on the master of client and server, where the Puppet master talks to all the different agents. So we have the Puppet agents running in all the different VMs to have the end-to-end connectivity. So as a first step, we get all the resource files ready. So first we go ahead and get the first worker node ready. So in sequence, we get in automated fashion, the installer gets all the worker nodes, Kubernetes worker nodes that have been configured ready. So now we have worker node 1, worker node 3 is up. Now worker node 2 is up. Now we install the Puppet agent in the VCA node. Now we start the configurations. So the way we have classified this is we have a notion of what are the softwares that needs to run on each node per data center per site. So this gives you complete flexibility in terms of what are the softwares you run on each environment. For example, I can have a separate configuration for a pre-production as opposed to a production. I can have different sets of softwares, not just configuration running on each one of them. On all can be controlled through a central agency. So when we link this back to the end-to-end topology that we saw, now this gives me flexibility to control all the data centers starting from the national DC all the way up to the HDC. So now Kubernetes cluster is coming up now. The nodes are joining the cluster. So as the nodes join, as the next step, now we'll start installing the actual pods. We'll start, it will be the stateful and the stateless pods. So next we go ahead and update the configurations. So these configurations are not just doing the install procedure. This can be updated during runtime as well, based on which service that any particular service you want to either update for config or for version. So and finally we install the CLI and then complete the installation procedure. Any questions on this? Okay. So I'll move on to the next demo then. So initially we saw in the first video we saw the installation procedure, where we saw an ability to from a centralized position to cross across the entire operator network topology for distributed computing, etc. So now we see an upgrade procedure. So when it comes to upgrade, so in terms of upgrade installation, we use the exact same software, a single entity, a single interface. We have a UI that's almost done for it as well. So with this, you have an option to just upgrade just one service, or you can upgrade the entire OSM package. So in this particular demo, we'll be upgrading the entire OSM from one version to another. So as you see on the screen right now, we give a -all. So that means upgrade all to a particular tag. So we are going to go ahead and do the update procedure. So I'll probably fast forward a bit as the video captures each pod getting updated. So now all the pods are updated. So we can now go and check. So we see that the new pods are initializing. And with this, of course, they'll go to the running state. So with this, we see an ability to also upgrade it. This upgrade could happen either in a centralized installation or, as I showed in the assurance workflow, if the monitoring, for example, is distributed across the different data centers. So now we see here in the video, all the versions are now updated to the new one as we had commissioned it. So any questions on this? So now we'll move to the third part of it, which completes the one perspective of OSM being operationable to manage the entire network. So Kubernetes, of course, so far we have seen installation and upgrade, and of course Kubernetes itself brings in support for scalability. But one more feature that we are very excited about, which we are bringing in here, is in terms of the stateless pod, it's fine. It can for Kubernetes, it's a flat network where it can scale across any nodes. However, for the stateful nodes, the scaling would still require the volume to be scaled as well. So that is why we have bought an OpenEBS to bring that extra high availability and resilience, where OpenEBS scales the volume as well. So what power this gives us is, in deployment, a stateful pod can also be scaled like a stateless pod in terms of not having a requirement for node affinity. So in this example, we will quickly take a look where OpenEBS has already taken care of the replication, and then we down one of the nodes. However, the data is already replicated, so the OSM service is still up and running. So for this, first we check if all the pods are in the running state, and then just to go forward a bit, we get the information on what is the persistent volume that we want to kill, and then we find out, post that, we find out which node is running this pod. So now we have got the volume. We have got the volume claim right now. So next we'll go ahead, get the node information, and then SSH into it and actually kill the volume. So here we get the name of the node, and with this name of the node, we go ahead and we delete the volume. So post deleting the volume, just to check that the replication has occurred in this in this scenario, we will go ahead and log into Open Source MANO and see if we are still able to access the database, access the volumes. So here we have gone ahead and deleted the volumes. So once this is done, we'll go ahead and log on and see where we are still able to access the. So we see here that we're still able to add a new vim, etc. So so what this demo is to show is the extra notion of availability and resilience that we have brought into TEOSM for the carrier grade readiness. So any questions on this? Okay. So so with this, we'll move on to the final part of this installation thing, where we will look into the multi-environment scenario. So in an actual deployment, we might have like a pre-production. We may have a staging. We could have a development environment, a production environment, a blue-green environment. So in this short video, we're going to see how, using this Puppet-based Gallop infrastructure, we are able to maintain different environments for installation. So, for example, a new version of OSM can be added to a pre-prod to test it, or the same mechanism can be used for IT apps as well. So since it's a generic infrastructure, This upgrade downgrade can be used for IT apps as well. So the way we have built it is to have a notions of data and manifest where you can template the softwares that you need and the configurations that are required for it, and then encapsulate it in different metadata of production. So with this, based on which environment that you are using, that particular update or installation is pushed to that environment. So we first look at so we can first start by looking at an example of a production environment. So as I said, the installation script, we have a singular script based on whether it's for the environment, production, or scale. So we'll go ahead and invoke that. But before that, let's check what the environment is. So as you see in the video, the current environment is set for production. So when you set it for production, automatically the associated list of softwares and configurations and templates are identified, and that particular subset or identified version is what is pushed to that particular environment. So as an example here, we are going to install a particular version of TEOSM, and based on the actual tag, it decides what goes to production and what goes to development. So in this example, we are installing to the production environment, which we will see it in a log right now. And then after this, we can repeat the exercise for a development environment. So this is the notion of installation at the. So here we now see the configuration for production happening based on the set of softwares and configuration. We see the log for it here. Similarly, as we go along, we see the same for development as well. So just to give you another overview, here is an example with development where we are again able to specify the configuration and softwares. So now, so this completes one series from our side where we saw an ability to install across data centers, mention different sites, and upgrade downgrade procedures. Now we take a slightly different look. So even when we show the integration with OSS and OSM, one of the main functionalities would be like an workflow automation, where I am able to pre-specify certain workflows. It could be it could be for CI/CD, it could be for a fulfillment workflow, it could be for an assurance workflow, to ensure I'm able to track and automate the task across the different telco and IT apps. So in this video, we'll see two examples. In one, we look into an example of fulfillment workflow where we are able to. So what we have done is we integrated the BPMN engine with TEOSM. So through this, we will drive a fulfillment workflow with a demo e-commerce app, and post that we'll see the same example for a CI/CD workflow to see what power we get out of it. So this is the high level idea where for the first demo where there's an e-commerce portal through which I can in the digital transform space, a customer can order a service, maintain a service. It can be a self-care app as well. And then there is the Suit CRM, which can be Salesforce as well. We're done for Salesforce for a customer. And then through the integrated BPM and business workflow automation engine, we are able to drive the required fulfillment workflow. So this is the demo portal, e-commerce portal through which a customer can order a product. So currently we have one sample product, a Suros image, which can be purchased from here. So this is the CRM part of it, where which will be holding the products and the orders. Currently, there are no orders. We can do the same check in Open Source MANO as well. The service is not initiated. So idea behind this is to show that currently there are no services or orders in the CRM or the orchestrator before we actually initiate the purchase from the e-commerce portal. So here we see the example of the BPM and workflow that we have created for this particular example. So a simple example where we are able to get a token to the BPM engine, create a Vim account, and then upload the required VNFT, upload the NSD, and then create the NS instance based on the order fulfillment of from the e-commerce portal order. So to complete the workflow, we'll go ahead and place an order from the portal. So as we place the order, the BPM engine that we have integrated with TEOSM takes over. It drives the workflow where it goes to the CRM, it checks the product validity, it gets the details, it registers an order there, which is what you see on the screen right now. And then in the workflow procedure, it triggers OSM to actually go ahead and fulfill this order. So now that the order has been placed, we'll be going ahead and let's go to OSM and check if the workflow automation has actually worked, and then we are able to see the NS. So here we see the successfully created NS instance, which was completely driven by workflow automation based on BPMN. So this another quick example of the power of this BPMN integrated is CI/CD. So for an operator, CI/CD can be in the software centric world, it can be a big challenge in terms of the number of VNFs, CNFs, the combinations of VNFs and CNFs that constitute a service, which can come from a multi-vendor ecosystem. So we're looking at multi-pipeline, multi-factory delivery chains in the software world. So here again, the BPMN plays a part where it can work, where we have written workflows where we can mimic vendors and taken these VNFs, CNFs and build governance chain into it, 2 levels of governance. So one level of governance to ensure that the candidate is right based on certain tests, and a second level of governance to ensure to see whether this is something we actually want to deploy in production. So these are 2 examples. And finally, just to wind up the demo part of it, to increase the efficiency of the O&M, we have also built an Angular-based UI for TEOSM. So this gives us an ability to move to a modern framework where, since in the software-centric world, okay, we talk about the multi-DC, we talk about the distributed deployment, but we need an elegant way to manage OSM in these complex environments. So we have authored a brand new UI based on Angular, in which we are able to do this with end-to-end. And as the next step, we are also bringing in all the data from Prometheus, ELK, and the Kubernetes as well. So in one integrated dashboard, not only can we see all the fulfillment workflows, we can see the entirety of the assurance workflows as well. So this overall covers, the way we see it in terms of, OSM, and in particular TEOSM readiness to, operate on the different operator networks end-to-end in terms of deployment, maintenance, operations, and O&M. So this is just a general roadmap of TEOSM, where currently we are up to release 7, and we are slightly ahead of schedule. As you can see, only in the next release we're talking about multi-environment. We already support multi-environment. We already are adherent to all the security standards like SIS, NIST, OAPS as well. And moving forward, the next key goal for us is to further improve on the resilience by bringing in cluster level resiliency as well. So that's something we are working on right now. So any questions? So Francisco, I'm done from my side.
Okay, thank you very much. So, is there any last chance for a question, Ramesh? All right, thanks a lot for your presentation. Quite interesting.